In this video, I will walk you together with my friend over here, who's always smiling, you see, through the solution to a common type of exercise in multivariable calculus, which is finding the equation of a tangent line using the gradient vector. So you're given something that looks like the following. X squared plus y squared equals 4. You're given a point such as the root of 2. Now this procedure is quite elaborate, so it will take a few minutes to do it, okay? So you've got this. Let's draw that first. That is a circle in the xy plane of radius 2, because that 4 really means 2 squared, so their radius is 2. So every 2 spaces is a 1 for the sake of making things easy to see. So draw a circle. Okay, so there's our circle more or less. The point, the root of 2 comma root of 2, that roughly falls maybe here. Okay, so that is the point of interest, and at that point we will find the tangent line to the curve x squared plus y squared equals 4. And we want to use calculus that is, the multivariable using gradients. So the first step is to recognize the following. You've got to take this and rewrite it as a function of 2 variables. So to write it, you would write f of xy equals x squared plus y squared. Okay? This is just one level curve of this function, nothing else. Now from the gradient, by taking the partials with respect to each variable. So the gradient is 2xi plus 2yj. Evaluate the gradient at the point the root of 2. So the root of 2 and the root of 2 going into the gradient vector gives 2 times the root of 2i plus 2 times the root of 2j. So this is the actual gradient at that point, so we may sketch it now roughly as, it's quite big actually, so these are the components of the gradient, that is the gradient, okay? And this is the x component of the gradient, and this is the y component of the gradient. So this is the rate of change at this point in the x direction. This is the rate of change at this point in the y direction. So with this in place, what we're going to do next is the following. Let's draw a picture of the quantity to be found, which is the tangent line in its equation. So that roughly looks like this. Okay, the orange line at that point. And the key step to observe here is the gradient and the line are perpendicular, so they meet at a 90-degree angle. Because with that in place, still smiling, with that in place, you can find what you need, which is this. You have to take the dot product, so to speak, of the gradient and a little vector perhaps along the line, okay? So here it's helpful as a mnemonic device to define the following. dr has these components. X minus the root of 2, which is coming from here, and that's the x component, plus y minus the root of 2, and that's the j component. Okay, there we are. And then to find the equation of the tangent line, we observe the following. The green arrow and that line are perpendicular, which means that the dot product has to be 0, which means the following is true. The gradient dotted with this little dr here, okay, is 0. That's the equation. With that in place, you write root of 2 I plus the root of 2 times the 2 here, j. If you dot this with that vector, which is x minus the root of 2i plus y minus the root of 2j, all of this has to be equal to 0. Okay, so it got a little crowded there. I hope you can see it well nevertheless. Let me move my friend here. So now we apply this dot product, which is 2 times the root of 2 multiplying x minus the root of 2. Okay, remember this is multivariable calculus. These procedures are elaborate because this is the mathematics. All right, then you add to it 2 times the root of 2 multiplying y minus the root of 2, and all of this equals 0. Okay, so this is the equation of the tangent line in very raw form. You may want to simplify it. Now here to simplify, let's see. You have to distribute, so we'll have now 2 times the root of 2x minus, and then we're just going to walk you through this in words. 2 times the root of 2 times the root of 2 is just 4. Okay? So the root of 2 times the root of 2 is 2. 2 times 2 is 4. Plus 2 times the root of 2 times the y. The same thing over here, so this is also minus 4. And all of this equals 0. Okay? So at this step, simplify. So we have 2 times the root of 2x plus 2 times the root of 2y. All of it equals positive 8. Move the 4's over, add them. Now just divide out 2, because that's a common factor. We can just divide it out, so all that remains is the root of 2x plus the root of 2y equals 4. And this quantity that you see here is now the equation of the tangent line. In this context, as you can see, it's quite an elaborate procedure. You've just got to smile through it the way he is still smiling. Pat yourself on the back for reaching this point in calculus. Puts you in a very rare kind of, category of people. So what we have is x squared plus y squared equals 4. The point is the root of 2 and the root of 2, which here almost looks like our eyes with a nose. You've got your circle. That's the gradient vector. Take this quantity and rewrite it as a function. So you've got x squared plus y squared. The constant is like a level curve, so that is the circle. Evaluate, set up the gradient, evaluate at the point. As a mnemonic device, introduce this little dr, which you can imagine roughly to be like a little vector along that line. Okay? Now that vector dotted with that little thing has to be 0. So the gradient dotted with the r is 0. So that gives rise to this. Apply the definition of the dot product. And the rest of it is algebraic simplification. And you end up with this as the equation of the tangent line at that point using the gradient. That is it. So thank you for watching. Have an absolutely amazing day. Don't forget to smile.